Kia ora everyone. So welcome to our Arch and Z webinar today. Today we're going to be looking at quantifying rockfall erosion and drivers in a valley with rapid glacial retreat using UAV-mounted LiDAR and in-situ monitoring. This is going to be a very exciting topic. We're looking at Fox Glacier in the South Island, which is the third largest glacier in New Zealand. Some fun glacier facts for you today. So I'm just going to start by overviewing our last webinar, and then I'll introduce everyone to Jason, and then Jason will take over from there. As always, please remember if you have any questions, put them in the questions tab in the GoToWebinar panel, and we'll have a Q&A session at the end. So for our last webinar, Lennon and I did a technical training update. I went over all the Register 360 Plus updates, and then Lennon went over the 3DR updates. So you can now access this on the Arch and Z website and go back and watch there. So if you haven't seen this one, we really recommend that you go and give it a watch because there's lots of exciting stuff in there. One of the things we showed was the new updates to the architecture behind Register 360 and TrueView. So what you're seeing on the screen here now is some of those improvements in the visualizations with the new TrueView viewer and LGSX format. You'll also find that the data of the new output files is much smaller and the databases are much more compressed. So always a major benefit when you're getting reductions in data size when it comes to reality capture data. I also spoke a little bit about some of the updates to the classification manager. So on the right-hand side, you can see the before and after for using the update clouds cloud points, where you can choose to remove like trees automatically from your classifications. I went through the database conversion process just to highlight some of the ins and outs there of managing that, and then also spoke about this new level from DAC when using a plot control. So you can go and watch the webinar, and Lennon and I are also happy to go through some of that stuff with you in your offices if you want one for your office. Lennon spoke about some of the 3DR updates for the 24 version. So he was doing a lot of the pipe extraction workflows, which are really exciting. And he also spoke about the AEC and BIM scans plan updates. So he was giving a few examples there, which are really awesome for that whole process. So after we did that webinar, the next day, the 24.0 edition of Register 360 came out. So that is now available for you. So we really recommend that you go and update the 24 editions of both 3DR and Register 360. So on to today's webinar. This one's particularly close to my heart. This is actually how I discovered the world of reality capture. I was doing photogrammetry to look at how the glacier was retreating over the summer melt season. This was back in 2015. And at the same time as that 71.5 meters of retreat I saw in the glacier terminus, there was also 47 meters of slope collapse to the side of the glacier. So as these glaciers retreat and reduce in scale, you get a load of rock fall around them. The rocks can be the size of cars, that's pretty scary. And Jason has the great job of getting to go and quantify all of these rates. So really awesome that he's getting to do all of this and that this is an area that's being constantly monitored. So Jason works at GNS Science in Wellington. He's an engineering geological surveyor, and he went to the University of Otago and did the Bachelor of Surveying in there. So super excited to hear from you, Jason. And without further ado, I will pass over to you.
Hey everyone, thanks for the introduction, Kirsty, and thanks for inviting me along. I think Kirsty gave most of this introduction. The main thing is an engineering geological surveyor, which are kind of three titles in one, but basically I'm a surveyor that works in the landslides team using terrestrial laser scanning, UAV LiDAR mostly, and got previous work as a hydrographic surveyor. So here's our UAV LiDAR. It's got 4 components, which I won't really go into great detail, but thought I should show a picture of it first. So this is all part of a project, a climate-induced landslides project, which is funded by MB. These are a couple of other images from our climate-induced landslides project. In the top right, there's a hill slope, well, quite a few hill slopes in the, I think, Gisborne or Hawke's Bay region that got decimated in a storm. I don't think it was landslide Gabrielle, but they had very similar sort of effects. In the bottom right, there's another large rainfall-induced landslide in the coast up in Gisborne. Usually, things of that scale are only seen in earthquakes, but so it's quite a bit of interest to us. Yep, Fox Glacier. Kirsty knows a lot more about it than I do, but it's we're going to be looking at Rapanui and Vic Falls mostly. And can I get a pointer here? Okay. Rapanui and Vic Falls, and a little bit about Keir Point later on. But those are our four monitoring sites down there. This is a time lapse over 6 months. I think this was back in 2015. You can see the rock slope on the right-hand side slowly just falling away as the glacier is moving down the slope. And yeah, so basically glaciers hold up rock slopes. So as they retreat and thin, the valley walls become destabilized and there's increased rockfall activity. But what we don't know is how often this rockfall is and what the magnitude of the slips are that we expect from them. So that's what we're trying to find out. That's another photo, 1950 to 2015, from roughly the same location. Quite a big change. So these are our monitoring setups. We've got a weather station, which I think is this thing, and then a rain gauge, which is this thing, and this wire here is a crack meter or extensometer, which measures the difference between between cracks in the rocks, and it will detect change between those rocks, whether it's the rocks expanding or contracting due to weather, time of day, seasonal effects. We see all that sort of thing. And everything leads into here, which is just a box with all the electronics in it. There's a solar panel on the front. And that is combined with what I'm going to be talking about, which is our LiDAR data. So we've got 2 UAV LiDAR data sets already. And we're planning to go back in June. And we've got a fixed wing LiDAR data set from 2021. So when we're planning here, it's quite a tricky environment. And we've got to have 3 things when we try to, when we're planning, which is imagery, digital service model, and mission planning software. Problem is, they all work in kind of different heighting situations. So the digital surface model works in height above sea level. Our mission planning software is height above takeoff point. But then we've also got to make sure we're at any point we're not above 120 meters above ground level, directly below the UAV. Because otherwise we'll be breaking Civil Aviation Authority rules and regulations. So it's quite tricky when you've got undulating terrain like this. And this is just a GIF showing what we're planning off and what we get afterwards. It's an orthomosaic created by our camera on the drone. So there's a lot of shadow zones. The imagery isn't always super accurate, and sometimes the DSM on the slopes are not either. So when we get out to the field, this is in Rapanui. This photo is taken from our helicopter landing site, looking up at the ridgeline. So it's looking up over here. As you can see down here, there's a big debris flow, which is mostly avoiding where we are. And it's our helicopter site and our equipment site. So if you zoom in on our equipment site, this is from our first epoch. So that's just part of the orthomosaic we created. And then this is from our next epoch. And you might notice something different there other than the snow. That's that big boulder there that came down. So they're really real hazards that we've got to look out for. There's always rockfall when we're down there. Fortunately, it's usually on this slope that we're hearing it from rather than directly above us, but we're always keeping an eye out. And there's a lot of helicopter traffic in this valley, so we've got to be careful when we're flying the drone. We've also always got a helicopter pilot with us on the helicopter radios to tell us when we're allowed to fly, when we're not. So for planning, we can't break CEA regulations, so not flying above 400 feet. We like to fly in straight lines. It makes it a bit kind of neater and tidier. But when it's undulating terrain, you can't always really do that. You can use terrain follow, but for various reasons, we looked at the software options and they didn't really suit us. So we came up with this kind of hybrid solution of just flying across, dropping to a vertical waypoint, backing off a bit, flying across again, and back up. It's a little bit convoluted, but a bit messy, but we cut out these data of our decreasing altitude and increasing altitude, so makes it okay. So processing, we actually use 6 different software packages, and actually there's a 7th one there that is used for classifying the point clouds, which I haven't done in this scenario. But once we have a point cloud created, this is at Rapa Nui again, we can come up with a pretty dense point cloud. However, what was quite disappointing about this is because we couldn't really fly over the side of the cliff because of breaking the rules. The actual data on the cliff is quite sparse and it's not super great, but that's what we ended up with in July 2022. We're trying to work out when we would go back to site. And then in February, this happened, if it's going to play. If you look, keep an eye out up here. So this is a pretty large rockfall. This is taken by the glacier guides when they were down on the ice. They were pretty happy to be up valley a bit. And even the glacier guides are talking about how big this slip is compared to other ones. And the dust cloud goes all the way up the other side of the valley walls. But don't need to show that. You get the gist. Big rockfall. So July 2022, and we weren't really allowed to fly from the base in the past, but we kind of did some begging and some pleading, and glacier guides helped us get some new permissions, so we're able to fly from the bottom and collect a much more dense point cloud on the cliff slope as well. So we're pretty happy with that. So that's the cliff slope, that's the whole slip there. This is Vic Falls and Rapa Nui combined. Our orientation is looking upslope here. And in the bottom right, you can see those are the 4 missions we had to fly to collect all that data. So in the past, we've just done the pink, and then for Vic Falls, we've just done the yellow mission. But this time we're actually able to fly up the cliff from our Vic Falls site to gather all that data. Because the LiDAR looks horizontally as well as vertically. So we're able to collect all that data. And this striping effect is just artifacts in the color. It's not artifacts in the actual data. And then we still had a bit of a data gap in the base of the debris because there's a big hole down there. So we were able to the next day fly onto the ice with the glacier guides and collect mission 4. So now we've got a complete data set and we're pretty happy with that. The cliff slope around 380 meters to the top of the debris, and then another 100 meters to the hole in the base of the debris. So it's a pretty big slope. Now, if we're looking at the outputs, we're looking into the slope now. So that's the point cloud, and this is a change model between 2022 and 2023. This is made in like a Cyclone 3DR. It's not the best change model because our data from 2022 is not very good on the cliff slope. This is a change model just done on one orientation, looking directly into the cliff. So it's really trying to detect that change into the cliff, which we can see is around 60 meters at its worst. And this is just an interest thing I did out. It's for the rock. So it's the rock slope and the glacier around there. It's a profile through it, and it shows that between this is meant to be 2021, not 19. It's the glacial ice is thinned by 100 meters in 4 years. Sorry, no, 2 years actually. Yeah, so it's a lot of change up the valley. But because we have that 2021 LiDAR, we'll be able to make change models between that and our latest LiDAR. So you can see there's a lot more change that we can detect through this because they're 2 complete point clouds. That's what the glacial ice was in 2021. So we can only really detect through rockfall from above that line, that ice line. And so we made 2 change models. One's looking into the cliff above the glacial ice, and one's a vertical change model below the ice. So basically everything below that ice line is just how much the glacial ice has decreased. So at the worst, it's 156 meters. Yep, just went through that. That little blue patch there is debris from the landslide above, and the hole there is just due to an overhang, and trying to do a vertical change model with overhang doesn't really work that well. And that's the main area of Rockfall, which is 3.2 million cubic meters. It's not super accurate because it would be better if we had a more recent data set to compare it with, and also it doesn't detect anything below that glacial ice. So I conferred with ChatGPT and it told me it's 1,280 Olympic-sized swimming pools or 1.2 Great Pyramids of Giza. I don't know if that means anything more than millions of cubic meters, but maybe that puts into perspective a bit more. Who knows? Haven't fact-checked those figures. And 180,000 cubic meters of deposition. So this is looking from above. That's our before and after of the cliff top and that's where the cliff top is now. When I was watching the video, we knew about this big crack here, which was I think 7 meters wide and something like 30 meters deep. I thought that was the big chunk that came off, but turns out it's a lot more than that. And then on Christmas Day, our monitoring team at GNS Science, they're part of GNet, which do all the landslide activity stuff. A lot of you will have the app. It detected some seismic activity which wasn't really that representative of an earthquake. They traced it to, they thought it was a landslide activity, traced it to Fox Valley. And then somebody checked the webcam and saw this big dust cloud in it. So thought, okay, there must be another big slip. And there was. So I showed these two photos earlier in the presentation. And basically everything you see there doesn't exist anymore. It's all rubble on the ice. So that's the Kia Point after the slip. And that's another one. So that photo up the top right is taken from that location there. As you can see, it's quite a big bit of change. And that line there you can see on the cliff face, that's one of our cables from our equipment. So all the equipment's disappeared. And I kind of guessed where the slip was based on the photography, and that's kind of what I gather. And the blue is where the cliff top is now. The yellow is kind of where the cliff top was before, but it wasn't really a cliff top because it was gradual slope, really. So yeah, quite a big slip again. So because we're still collecting data for this, we haven't done a whole lot of analysis yet. So I grabbed these, this data that we did for another project out at Cape Kidnappers, looking at coastal cliffs. Just as some examples of what sort of stuff we can produce. So on the right is a change model, which I've seen. On the left is a different kind of change model looking at individual rockfall between epochs. And that's all dependent on how much time you've got between epochs and what your cell size is. But you're able to see exactly how many events occurred between the two. And that can feed into, on the top right is a magnitude frequency curve. So that's telling you over a certain time period what sort of rockfall is likely to be, is expected, and how big each of those rockfalls would be expected to be. And that can feed into hazard and risk models. And then we can also make digital terrain models and hillshade models. And just to finish off, it's a short one for me today. Kia, pretty annoying for us up in Fox Valley. We often leave out sacrificial equipment like this strap here. Some of these photos are from Fox work, some are from other work. But yeah, they attack anything you leave out for them. On those tubes on the bottom left, one popped out and then they chewed through that cable. And they've also chewed through that cable. And they're seeing what they can do with this big box. They will get at anything. At one of our sites, they actually unscrewed the 2-inch bolt that was holding this this flap, this door down, and they fortunately were not able to get into it after that because the lid was too heavy. But they got into all the electronics, that would have been pretty disastrous. Yeah, but that's all I've really got. Just want to thank people that helped with the presentation. It's definitely not all me.
I have I've got a few that have already come in, so I'll ask you those first, Jason. But yeah, if any more come in, I'll say them as we're going. Yeah. So the first one I've got here says, is this project ongoing? Do you typically go to environments like this?
Yeah, we do quite a lot of alpine work, mostly because that's where the large landslides occur, and we do a lot of kind of fundamental research into landslides. This is ongoing. As I said, we're going back in June, and I think we're going to try get back annually. Not sure how long for, but that's the plan. It's not always field-based though. We do a lot of work in the Southern Alps, but sometimes that's just it's remote, looking at satellite imagery and things like that. But yeah, we do get out there a bit as well. It's always nice.
Awesome. So are you doing like yearly visits?
To Fox, ideally, yeah.
And do you do any North Island based work as well, or is it all landslides based in the South Island?
No, we do a ton of work all around the country. We go up to Gisborne quite a bit, because they keep getting hounded by storms, it seems. But yeah, we're all over the country. Unfortunately, we have to drive everywhere because we can't take the drone and the plane because of the batteries.
Yeah, flying with batteries is always an issue.
Yeah, but it's good to get out and out. And, yeah.
Awesome. I've got another question that's come in here. Somebody said, do you study the other large glaciers? I think they're referring to Franz Josef and Tasman glaciers there.
Yeah. We've done a bit of work for Fox Glacier, Franz Josef Glacier. They moved the viewing platform a few years ago, and I think we had to do a hazard and risk analysis in the Rockfall above the viewing platform, and we decided it's at great risk, so they moved that. But I think more of our work there is related to is rather than research, commercial work from the glacier guides and things like that. But I don't know of any work we've got going on Tasman Glacier or any of the others. Kind of, yeah, this Fox is our bread and butter at the moment.
Awesome. And that kind of covered the last question that I just got, which was how you deal with the health and safety around the Rockfall itself when you're actually surveying there on site.
Yeah, well, we're not going to go back to Keir Point because that doesn't really exist anymore. And I heard actually this morning that there's some more seismic activity that looks like it could be landslides in Fox. So probably means some pretty big ones. So we're going to have to make some pretty big calls about whether we're going to go back to Rapinui or not. Yeah, it's kind of a judgment call. Basically, we're not going to go right at the base of the debris, and we're not going to go anywhere near the edge of a cliff. Yeah, we've got to fill in a lot of paperwork, and we're always just on not on edge, but on high alert when we're out there. Any rockfall, everyone stops and looks around and waits till they can see what they're hearing. And yeah, it's kind of just
Absolutely.
a judgment.
I remember when I was down there in the Rockfall. Yeah, I remember when I was down there in the Rockfall would like come down, but you'd often see it before you would hear it because of the way it would echo through the valley.
Yeah.
Well, that concludes all the questions that I've got. So thank you so much, Jason. We really appreciated you coming along today.
Yeah, thanks for having me.
Thanks. So we've got a few ideas for next time. We haven't confirmed the date yet, but we are speaking with a professor in Melbourne looking at doing automatic extraction of features from point clouds to create rivet models. So that will be quite exciting. Once we've confirmed, we'll send that out to everyone and let you know what's happening. But if you have any content ideas and would like to do a presentation on one of your jobs, we'd love to hear from you. So thank you very much, everyone, for coming.